And then finally, this afternoon, Dominic, are you there for us? Slides already.
I'm here. How are you doing there?
Not so bad, Dom. That's grand. It's all yours, Dom.
Cool. Okay. So yeah, thank you very much for having me. I'm Dominic Eggbeer from PDR Metropolitan University, and with my other hat, I've got a company called Trinity Creative, which I'll talk a bit about today and some of the experiences we've gone through. So I work with Tom and Mark Lloyd. So Tom's a brachial plexus patient. He paralysed his right arm in a bike accident, as you'll see, and Mark's a physiotherapist in the NHS and with his own practice as well. So it was von Hippel, I think, back in 1986 or so, he defined the term lead users, and they're basically the pioneers in the marketplace who are positioned also to gain significantly from finding a solution. So they're the true pioneers, and it's working with them that I think we've come up with some novel solutions, which nobody else has so far. So I met Tom, as I say, about 8 years ago, and this was following his rather nasty accident. So if you're squeamish, this gives you an indication. So he, like me, likes throwing himself down a hillside on a mountain bike, which quite often results in pretty nasty accidents. And this accident paralysed his right arm. So he wrapped his head around a tree, pulled all the nerves out of his shoulder, and paralysed his right arm. I just realised I haven't got my camera on here, have I? You can see me as well. So I'm standing up here. So it was a pretty brutal accident, and one that he wasn't really going to come back from very easily. It significantly changed his life. He was airlifted out into hospital with numerous injuries, the primary one being the paralysis of his right arm. So here he is, getting back on his bike, as any kind of lead user would, trying to ride again. So that wasn't going to stop him, and it was quite obvious from the outset he wanted to find a solution. This was about 11 years ago, back when mountain bikes had 26-inch wheels rather than 27.5 and 29 now. But it's not very easy to balance on a mountain bike with one hand. It results in lots of accidents, as you see here, so a solution was obviously needed. So this introduced Mark. He's a physiotherapist, so he works with people like Abby, for example. So he was keenly interested in Abby's work, and we worked in parallel, actually looking at wrist splint designs as well. And additive manufacturing is obviously one of these technologies that become massively accessible. I've got one right here. I've got a few more in my garage here. So we make extensive use of additive manufacturing. Mark was a keen pioneer who is also Tom's physiotherapist, so an ideal collaborator on this project. And he recognised obviously all the physical and psychological effects associated with these kinds of injuries as well. So it isn't just the physical injury of having a paralysis, it's all the psychological effects. And sport is actually an extremely good way to improve your physical and mental health and well-being. So there was an obvious need for people like Tom and his sort of position, extreme sports people, or even people who are born with a brachial plexus injury, to become more mobile and active. So that's kind of the why. So together, Mark, Tom, and a couple of other people actually in the co-creation process. In this case, I've got my sound on there. I've got a recording, obviously. Explored ways of using design 3D printing to create initially custom wrist splints, which. And there are some obvious problems. Abby's also probably highlighted a bit as well. So it leaves physical impressions if you just have solid edges and prominent parts stuck against your skin for long periods. But that was an important consideration in any of these kinds of products, be those cycling products or wearable technology such as splints. But in the very early days, Tom also experimented with thermoplastic materials, the kind of common stuff you can get in the NHS, just to make something that would get him bilateral control on a bike. So pictured here is a very basic device slung around a handlebar grip, which was just slotted on, and he strapped his hand to that, and that allowed him to gain some kind of bilateral control. But you're strapped to the bike. If you have an accident, you stay attached to that rather heavy bike, which causes some significant injuries. So I introduced to Tom when apparently he liked taking his shirt off and getting 3D scanned. So we initially explored the idea of 3D scanning to create a custom brace. And actually in the foreground in this picture, you can see a carbon fibre brace that he'd already had made by a specialist orthotics clinics using the traditional methods. He had to heavily modify that, so it was only made for him. And there were people knocking on his door. He's a social media savvy guy. There were people knocking on his door saying, where can I get one of these? They couldn't. So there was born the idea of using additive manufacturing to come up with first prototypes. And we've gone through so many cups of tea, so many cups of coffee, so much beer, so many pizzas and evenings doing this kind of work. Iterating quickly, prototyping overnight, trying it out, crashing it, breaking it, trying again. And this is the beauty of this kind of stuff. It allows you to do that really quickly in a very agile way. With lots of failures along the way, it has to be said. Using PLA and ABS materials, who hasn't encountered these kinds of problems? And they're ongoing. This hasn't gone away. But it did get us to a point where, here's me chasing Tom down on the trail, if you can see the video in the top right there. So it did get us to a point where we could have a testable product, even using really low cost materials with all their inherent limitations in mechanical properties. Not ideal, but it got us to that stage. And this didn't also incorporate a quick release, so this was just a basic device that you'd still remain attached to the bike. So the realities of lead user and co-design is you end up spending a lot of time making paper prototypes, mock-ups before you get to the 3D kind of printing stage. So this was a project led by an MSc student in product design school in our place, Poppy, who did her major project making the ideal kind of 3D printed arm brace. And it was the first of its kind. It allowed Tom to get on the bike, as you can see in the picture here, get a little bit of riding in and test that concept of could you do this using 3D printing? And the answer was yes, to a degree. She built in some adjustability into the spring mechanisms to give you a little bit of extra control and adjustability in the damper and that damper mechanism. And it allowed him to ride around a car park to a degree, and even try a little bit of off-road actually as well. So this kind of proved the concept that you could do it, but there were some significant challenges identified along the way, and this was about 6 years ago maybe. And this idea of a quick release mechanism and why it's needed is illustrated extremely nicely by this chap here. This is Chris, so he hasn't got a brachial plexus injury, but he was born without a hand. So we've adapted one of our devices, which on the test ride here, he managed to crash quite beautifully. Thankfully, everything worked nicely and it quick released and he wasn't injured. But it just goes to show the importance that if you're riding a heavy e-bike in this case, down a very steep bit of track, GoPros always seem to flatten trails, this is actually quite steep, you need to be able to release from that bike. So there's Tom and me having to apologise to the camera here after we crashed the customer on his first test ride. And again, we needed to refine this, and the quick way to do that was bend bits of metal. I mean, we've got access to garage, we've got access to 3D printers, we've got access to drills, all the basic kind of stuff. So you needn't have a fortune to do this kind of thing. And this is the reality of it. We're using basic springs, the kind of stuff you find in furniture, for example, is damper mechanisms to start with, just to get an idea of the kind of mechanics of it, the fit, and check the hinges are in the right location quite quickly and trial it really quickly to make sure that when we moved to the final solution, it was going to work. And by this point, we started using the Mark Forge manufacturing process. So I've got a Mark Forge Mark II, which is great nylon material, so it's really tough. It will flex, it will bend before it shatters and breaks, so it's quite a safe material in its braking characteristics, or its failure characteristics rather. So we used a combination of the Mark Forge additive manufacturing process in the prototypes, CNC machine or laser cut parts in the early days, custom dampers and some custom carbon fibre production as well. So you can use 3D printed mold tools and home layup carbon fibre. And it's moved us now to the point where we've sold quite a few of these in circumstances we weren't expecting. So the final product is actually manufactured in a combination of CNC aluminium by a company in China who seem to unfortunately hands down beat the UK in terms of price and speed and quality in many cases. Carbon fibre, so we have parts made in the UK. Damper mechanisms are all customised and made in a combination of places, and 3D printed parts as well, incorporating the quick release mechanism. So we're actually kind of selling these now, but we picked our customers very carefully. So one of the customers is Josh. He's a motocross rider, so we never really envisaged selling these to motocross riders, and the extremes are taken even more extreme in these situations. So we went to visit this guy racing, and he absolutely tore it to shreds, but it keeps going. We've had to modify and make little adjustments along the way, but I think this emphasises the importance of picking your customers as much as you're kind of picking your manufacturing processes and skills as well, because they'll test you, they'll challenge you along the way. So he's happily now riding along these things, hammering them with on his motocross courses. So in quick summary, really, using additive manufacturing, we really tested it to its limits. The kind of lower cost machines, the Mark Forge, have a really, really valuable place, and the Quiddy machine sat behind me is a great prototyping machine, but you do reach the mechanical limitations of the materials very quickly. As some of the other previous speakers have talked about as well, design automation would be absolutely brilliant. We've had to make it a very configurable design, so I've got one of the designs in front of me here. So this is all configurable. All the parts have to be adjustable to different people's sizes and shapes, because we've posted these to Australia, for example. We can't always take all the precise dimensions. We can't make everything custom. And that's a real challenge. And these go along with the challenges of running an extremely small business that exports globally as well. So it's a challenging but extremely rewarding area to apply additive manufacturing. And with that, hopefully, the sound and everything will work on this video.
I literally got my mum to stitch some Velcro to this glove.
Thumbs up.
And I put Velcro straight to the metal handlebar and just strapped my hand to it, which is a really bad idea. And when I got to the bottom of the hill, there was a lot of blood. I get a lot of satisfaction from overcoming these problems. And I guess maybe that's something which has really helped me, is I've learned to enjoy the process almost as much as the end result. And I think that's a big part of where I'm at now, actually. So I studied interactive media, and towards the end of my course I looked into wearable technology. I found it fascinating, like cyborgs, all that kind of thing, and how you could make the most out of your body. And little did I know that actually that can be really useful.
That's my conclusion. I'd be happy to take any questions, obviously, later on.
That's great. Thank you, Tom. That's lovely. Really nice work.